In this demo, we will see how we can achieve this epic with Mia Platform. I want to manage the life cycle of the infrastructural components that developers will use in their projects. We will start exploring this with a first story, impersonating a platform engineer. In this story, as a platform engineer, I want to set up a standard template for Azure Service Bus, so that developers can autonomously provision Azure Service Bus instances and topics by picking them from a self-service catalog. Before diving into the demo, let's see the main technical components which support what we will see. Of course, Mia Platform acting as a single point of contact, providing a central catalog of templates and orchestrating everything behind the scenes. Then, a Git provider to store templates, infrastructure as code assets, code and configuration, and also executing CI/CD pipelines. Then, a tool to manage and apply infrastructure as code. Lastly, a cloud service provider to provide runtime execution. Mia Platform is designed to be open and can integrate with a variety of tools, so that enterprises that already have some of them, which is the most common case, can just plug them. For this specific demo, we picked some common providers: GitHub for repository and CI/CD, HCP Terraform for infrastructure as code, and Azure for runtime. Now, let's start with the demo. Let's assume that we already have an existing Terraform module already defined and available in a repository. This module is to create an Azure Service Bus and is well structured with all its parameters and input variables to use it. We want to make it available to developers, so we go to Mia Platform software catalog and we add an item. We pick the right type, which is infrastructure resource. We give it a name. We have a lot of metadata which can help manage the lifecycle of this component, including the lifecycle status, categorization, metadata tags, and all that stuff. We provide an icon. We give this version a name and write release notes. And then we put a link to the repository which we have just seen to track the source, the relevant sources for this module. Then we have this part where we can define what actually is inside this reusable component and what will be asked to the developers which will use them. We have prepared the metadata used for this configuration, which is well defined and documented, but let's briefly see the main components. First of all, we have templates definition, where we provide a template for the output file which will be created, which is basically just a file related to the inclusion of the module which comes from here, so from the external GitHub repository where the Terraform module resides, into our project configuration, so the developers with complete segregation of responsibility can use it without knowing any detail about the actual contents of this repository, which is managed by other people. Then we have the JSON schema, which is a convenient way to define a form to help the user provide input information needed for this component to be instantiated and used. These are the two most important parts. And we create the item. The item is created, is inside our catalog. We can see Azure Service Bus version 1, all the data we provided, the asset definition, and so on and so forth. And this is what it looks like, the process to create a new item in the catalog for a platform engineer. But what this will lead to is developers to be able to create and use these components without knowing all the details about Terraform, as we will see in the next stories in this demo. In this demo, we will see how we can achieve this epic with Mia Platform. I want to speed up and simplify development and release processes with infrastructural components, self-service, and composability. We will see this with 3 stories, impersonating a developer. In story 1, as a software developer, I want to implement a new Python API starting from a template, so that it is built and packaged. In story 2, as a software developer, I want to self-service provision infrastructural components for my API, so that I can deploy and invoke it. Story 3, as a software developer, I want to promote my API, so that it is available for consumers in production. Before diving into the demo, let's see the main technical components which support what we will see. Of course, my platform, acting as a single point of contact, providing a central catalog of templates and orchestrating everything behind the scenes. Then a Git provider to store templates, infrastructure as code, assets, code and configuration, and also executing CI/CD pipelines. Then a tool to manage and apply infrastructure as code. Lastly, a cloud service provider to provide a runtime execution environment. My platform is designed to be open and can integrate with a variety of tools, so that enterprises that already have some of them, which is the most common case, can just plug them. For this specific demo, we picked some common providers, GitHub for repository. So let's start with the first story. As a software developer, I want to implement a new Python API starting from a template so that it is built and packaged. As a developer, I go to the console. I create a new project. I give it a name, like Terraform demo. I pick the providers which I need. For this demo, we are using, as I mentioned, GitHub. And we will start from a template for the project which is supporting Terraform. Starting from a template for a project means that you are inheriting several configurations like environments, which we are seeing here, and pipeline definition and all that stuff. Once the developer creates the project, here he can start working on the code. He can go in the design section. In the design section, he has access to the catalog, and he can browse the catalog element to find something which he can use to implement a Python API. So let's search Python. As we have mentioned, we are targeting Azure as a runtime, so we pick Azure App Python example. The way of creating this kind of elements is the same as we have seen in the previous demo story for the platform engineering team. So we call this application Python demo, and we create it. The console is taking all the required action to create also a repository on the selected provider. So you can see here that everything has been scaffolded starting from the template defined in the marketplace. So not only configuration, but also the starting code. In this example, the code is already providing a working endpoint. And the developer can finally start working, so he can copy the repository URL. He can go, for instance, to VS Code, clone the repository, and start working in the repository. Let's assume that we want to make some change, so hello my platform from Python in this video demo. Okay, I do this change, I just commit it. Here the developer would of course implement the feature that his API needs to do, or his application, his microservice, his whatever in general, and I push to the repository. This will automatically trigger another behavior which was tailored inside the element in the software catalog, which is the predefined pipeline for this repository, Python demo. In fact, as we can see, the pre-configured pipeline created from the template has started building after our commit. He built the initial version, but he is also now building the new version of this application based on our last commit. We can see that the pipeline completed. So the code has been built and the asset has been posted on the asset repository, which will be used later. Of course, this can be all templated, how this Python pipeline is constructed. So this is all part of the, let's say, governance framework allowed and implemented by the console. And we can save configurations inside the console, providing a message. Now let's move to the story number 2. As a software developer, I want to self-service provision the infrastructural components needed for my API so that I can deploy and invoke it. Let's go back to the console, exactly where we left, and let's move to the infrastructural resource section. We can search for the required components. In this example, we have told that the Python API will be delivered with a Terraform Azure App Service, so as an Azure App Service. I pick this from the catalog, and I can see the form which has been prepared for us by the platform engineering team, which added this item to the catalog. So here I don't have complex technical information required to consume this component, but I have just what the engineering team, the platform engineering team, decided that would have been manageable by the developers. I pick the name of the code which I want deployed into this Azure App Service, and I give it a name. Okay, as you can see, we have everything well guided and defined. Also, just to have a link with the first use case that we have seen, let's assume that I need a service bus. So I pick Terraform Azure Service Bus from the catalog. I give it a name. Also here I can have different information which has been defined in the item catalog definition by the platform engineering team. I can also provide queue names. And I add also this one to my project. I save the configuration, and from the developer perspective, everything is ready to be deployed without messing with any specific detail about Terraform. But let's see how this works a little bit behind the scenes. We go to the deploy section, we pick the revision that we want to deploy, and we see what will be deployed. What happens behind the scenes is that based on the information provided by the developer in the form inside Mia platform and leveraging on the form defined by the platform engineering team inside the item in the software catalog, these files are produced. So for the, for instance, for the Azure App Service, I have this Terraform variable file which has been defined, pre-filled with the information provided by the developer, and linking to the external Terraform module which will be used to implement this. But as you can see, the actual Terraform module code is not present here, is hidden from the developer, which is just providing input information. Starting the deploy, we are basically triggering the pipeline which was defined as part of the project template, so something which is related to how this kind of project are deployed. We can go to see the pipeline. The pipeline is doing a lot of stuff, including actually integrating and starting a run on our Terraform instance, because another thing that the Mia platform did behind the scenes was creating one workspace in my HCP Terraform account for each environment that I have defined in my console. So here I can see that this run triggered by the pipeline has arrived, the plan is finished, and the request is just to add, as you can see, the Azure Service Plan, the Linux Web App, the Service Bus, and the queue. And now this is being applied. This will take some time. If you want to skip ahead at the end of the creation, you can do it. We keep the video in one single take, but this is just Azure creating components. So we can also go directly into our Azure subscription and see components which are actually being created. All this stuff that I'm showing is what happens behind the scene. The developer is just waiting for the deployment to complete. He has access to the details of what's going on if he wants to, as we did here, looking at the pipeline, etc. But if we want to keep the developer, let's say, separated from these details, he can just wait for the deploy to complete or close the deploy request and monitor it later here in the history. Let's see if the application has already been created and started, the API. It seems that it's not yet started. The container is started, but the application is still not deployed in it. This because after creating this part, Terraform is also creating topics, requested topics. All the infrastructure provisioning part takes place before the code is deployed inside the Azure app, because this is how it works. So you create the service, you create the app, you complete the provisioning of all the infrastructural components, and after that the pipeline will push the code inside the Azure Web App. So the Azure Web App is here, but it's still not it still didn't receive the code to be deployed. Okay, so the Terraform has been applied. The pipeline is continuing. And we'll now proceed to deploy the application. Application deploy has started based on our configuration. As you can see here, the package with the source code that has been built during the story that I have shown you earlier is being deployed to the app service. this kudu is something which is internal of how Azure App Service works. It unfortunately takes some time. Okay, everything is finally complete. So the pipeline completed, so the application has been also deployed. And as soon as Azure manages to actually spin up the provided code, we will see the new API, the new Python API answering with our hello world here instead of this welcome page provided by Azure App Service for Python. Here it is, Hello My Platform from Python in this video demo, which was the updated message which we provided. And this closes our story. Of course, the developer gets this feedback. Okay, now let's see the third story, the third and last story for the developer. I finally want to promote my API so that it is available for consumers. So here we will see basically multi-environment management. We go back to our project in the design section and we do the little changes that we need to make this application compatible with multiple environments, considering that in our setup we have one single Azure subscription, so we need to differentiate instances with some other way. Just for the sake of this specific example, we are using distinct service name for services of different environments. So, for instance, we change this, we want this service name to be Terraform Demo Mia for dev and Terraform Demo Mia prod for production. We can achieve this by using variables in Mia platform. Which are as simple as this. So for our app service, let's use app service name. We go to the public variables and we can define the name for each environment. So Terraform Demo Mia for development, Terraform Demo Mia prod for production. And here the key is app service name. Then we can do this also for the service bus. So service bus demo Mia, we replace it with a variable. Bus service name. And we define also this variable here. Okay, as you can see, it is super easy to manage multiple environments. You can define variables, both public and secret variables, where you can define different values for different environments, and you can just use these variables inside any descriptor. What does this mean? This means that when I go to the deploy section now, if I'm going to deploy in the development environment, my main revision, I can see that the service name is Terraform Demo Mia, while if I go to the production environment, again I pick my revision, the variable has been interpolated with the other value, so service name is Terraform Demo Mia production. This is not only, let's say, something that can be used in this way, but is also super useful for other application purposes. And again, let me remind you that this is just because in our current setup, we have a single, in this demo environment, a single Azure subscription with no stronger segregation between environments. Otherwise, it would have been also, could have been also made, let's say, easier and more structured. Let's deploy to production our revision. We just click on deploy. Considering it's a production environment, we get this warning to confirm before deployment. And this starts basically the same stuff that we have seen earlier. So the developer can just sit here, relax, as is suggested here, and wait for the pipeline to complete. Otherwise, we can go see what is happening. So again, the pipeline is triggered, and the pipeline itself has triggered or at least is triggering here, the run on Terraform. Now everything is environment aware, so this time the run has been triggered on the production workspace inside my HCP Terraform instance. In fact, as we will see for the plan, all resources will be created because these were non-existing before. If I would have deployed this to the development environment, I would have had an empty plan, at least for the Terraform part. And now, in the same way as for the previous story, Terraform is creating and provisioning all the infrastructure while the developer is just waiting, or maybe he closed this section and is working on something else. Now, I wouldn't wait for everything to be created as we did for the other video. Let's just see that at least these couple of components are created. So here, as you can see, the app service plan and the service bus, for instance, has been created. In this demo, we will see how we can achieve this epic with Mia Platform. I want to efficiently monitor and troubleshoot my enterprise systems. This is a broad topic. Mia Platform offers several ways to integrate existing monitoring tools. Also, it provides some built-in capabilities out of the box. We will give a quick look to the topic with 2 stories. In story 1, as a DevSecOps, I want to check environments and applications so I can monitor their status. In story 2, as a software developer, I want to leverage AI to troubleshoot a problem in my application so that I can quickly fix it. Let's start with the first story. Well, this can be done by leveraging on the capability that Mia Platform offers to integrate external dashboards, whether they are custom dashboards built for the purpose or dashboards coming from existing tools like Dynatrace or Grafana or Logstash or other commercial tools. Here, for instance, we have built this simple dashboard to monitor our Azure runtime. You can see how all resources are listed. You can see also details about the resources, like the queues inside the service bus that we just created with our previous stories in the demo. This is possible because Mia Platform offers these extensions capabilities where you can define a lot of integrations in different parts of the console with different integration ways to allow to have a single glass of pane where even external tools are integrated to reduce the tool switching effort for developers, for DevSecOps, and for all the people who needs to access this kind of tools. Now, the second story is about a software developer trying to leverage AI to troubleshoot a problem. Let's move to a project, for instance, this MiaFlow project. You see that there are unhealthy pods. So this, for instance, is a high-level monitoring capability which is provided out of the box by the product. I can leverage on Mi Assistant, which is our AI-powered assistant, and ask something about this project, like why there are unhealthy pods in this project. Help me troubleshoot. This is not a simple chat, but is leveraging on the power of MCP servers in order to retrieve all the relevant information, not only from the configurations inside the console, but also from other tools. So for instance, here, the MCP server inside Mi Assistant is retrieving the running pods, the debugging information inside it, the Kubernetes events. He is accessing also the logs and is helping me identify and troubleshoot the cause. So as you can see here briefly, in this application, there are a couple of environments. There is a root cause, there are missing Docker images because there are these image pullback off errors. And also, of course, the AI is able to help me fix these issues. This is way more powerful than leveraging on external tools in a standalone way, because in the console you can have all the context, your application, your infrastructural resources, and all the elements needed to have a proper context so that AI can effectively help me in these tasks and not just provide general purpose information. In this demo, we will see how we can achieve this epic with Mia Platform. Provide developers a curated catalog that keeps everything in sync with corporate standards, managed by the platform team, automated for the developers. We will start seeing this with 3 stories. Let's go. In the first story, as a platform engineering team member, I want to import existing standard Terraform modules in the platform catalog so that I can manage their onboarding and lifecycle from a single centralized control plane. For this demo, we will assume we have our private repository with our enterprise Terraform modules. This is just a sample repository with several modules available in it. So for Azure App Service, for instance, where we have all the standard files of a Terraform module, including input variables definition. How we can do this? We go to Mia Platform console, we go in the Terraform importer section, and what we need to do is just to scan a new repository here, add the repository URL, select a branch, and scan repository. In this way, Mia Platform will scan all the repository and find reusable modules. As you can see, we have the 4 modules that we have seen before. In this way, we don't need to rewrite existing modules, but we can just leverage on them by importing it in Mia Platform. Let's import, for instance, storage and service bus. When I click on import selected, the modules are scanned and imported in the console. Everything is tracked in Mia Platform unified software catalog. So, for instance, I can go and see the details of the storage item that has been created in Mia Platform. In this page in Mia Platform, which is a page in the software catalog item, I can see all the versions that I have imported, because also Terraform importer is able to track updates and to manage the complete life cycle of the corresponding item in the software catalog. I can go in the first version and see all the details that have been imported from the catalog. Now, the second story is about a platform engineering team member that wants to import Terraform modules, but from public registries instead of from a private repository into the platform's catalog, so that I can govern their distribution from a single centralized control plane. How we can do this? We just go back to our Terraform importer. We, instead of selecting GitHub repositories as a source, go to the registry modules. This page is actually connected to the public Terraform registry. You can pick the provider that you need, and you will be able to browse all publicly available modules with some details. Let's search, for instance, for Avinet in Azure. I decide to use this one as a platform engineering team. I want to make this available to my developers. So I pick this virtual network and I import it in the catalog. Import is completed. This is not just for Azure, of course, but can be applied to any provider. So I can go to AWS and pick, for instance, an S3 bucket. I pick this one, maybe, that has a higher number of downloads. I select it and I import it. That's it. For both the component that I have previously imported on Azure and for the one that I imported now on AWS, I can go and see the corresponding item in the marketplace. So for Azure, I have this page, which is completely analog to the one that we have seen for the import of private Terraform modules, where I have the versioning and I can manage all the life cycle of the corresponding item. In this way, I can govern which components are made available to my developers for their automation and usage in the projects, instead of just pointing them to public registries, losing the control. Of course, the same applies for the S3 bucket, which has its corresponding item in the catalog now. Now, let's switch point of view and let's impersonate a software developer. As a software developer, I want to access a single unified catalog for all my infrastructural needs, regardless of the cloud provider and the source of the module, of course, and maybe also supported by AI, especially in the discovery part, so that I have a consistent experience without needing to learn different tools or access multiple user interfaces. So now I am a developer. I am in my project where I would develop also the code. I go to the infrastructure section and I can start using the components which I have already imported thanks to the Terraform importer. I can see that I have in one single unified way both the modules imported from the private registry, like Terraform Azure Service Bus and the Terraform Azure Storage, and also modules imported from public registries, so my VNet and my S3 bucket. I can add them really easily in the same way. So for instance, for the service bus, I click on it, and I will be guided in providing all the necessary input variables and specifications for the module to be used in my project. So for instance, a service name, resource group name, and all the details related to this specific service. The same applies, of course, also for other modules. For instance, the S3 bucket, which I imported from the public registry. The input variables have been parsed and transformed into an easy-to-use form where the developer can provide information in an easy and guided way instead of having to browse public repositories and all that stuff. As I was mentioning, we also have the capability to explore the marketplace with AI Assistant. So for this specific demo, we will have a simple prompt, just asking directly for one specific component. So I need to build an application using Terraform Azure VNet infrastructure resource. Is there something ready to use in the catalog? This is just a simple example to see the capability, but of course this gives a lot of value if it's used for more complex scenarios where I can use AI to search on the marketplace to find all components needed for my complete architecture. So I can give maybe just a definition of what I need and have the help of AI in defining the whole architecture of my application. As you can see, the item has been found. Here I have some details which have been reported for me. And also AI suggests me other related Azure Terraform resources which are available, which are other components that are in the catalog. So we have seen how we can provide developers with a curated catalog that keeps everything in sync with corporate standards. And that catalog is managed by the platform team and is automated for developers' use.